Minute Math. When you need help, you use Minute Math.
I'm Sean Gannon, and this is Minute Math. Today, we're going to learn about differentiation, and we're going to use the power constant and sum rules. We're going to differentiate each function with respect to x. So if I was given this function, y equals 5. Pretty simple function from the beginning. Y just equals 5. 5 being a constant, and that's the key. It's a constant number. So we derive that. When we derive a constant, this works for every single constant, deriving with respect to x. When we derive a constant, derivative of every constant is just 0. That's it. F of x is equal to 5x to the 18th power. Okay, so 5x to the 18th power. Well, right here, I'm going to be using the power rule. Okay, so when I take my derivative, f prime of x, this exponent, this power, is going to come down up front. So we have 5 times that power, 18, times x to the power of 18 minus 1. We take whatever that exponent was and we subtract 1 from it. So we bring the power down, bring that power down, right down in front. So 18 comes down here. And then, it's all multiplication, then, or you can put it out front in front of the 5, doesn't really matter. And then we have the 18 minus, we take that power, we subtract 1 from it. So let's simplify this. So at this point, I've already taken my derivative. So f prime of x is equal to 5 times 18 is 90. 90x to the 18 minus 7, or 18 minus 1 is 17. And there is my answer. F prime of x, derivative of f of x, is equal to 90x to the 17th power. Y equals 4x to the 5th plus x, just x right there. Okay. Well, this one, I'm definitely using the power rule, and they're using sum rules. And what we're combining here is when we take our derivative, we can take the derivative of each part individually with that plus sign in between. Now, sometimes people like to write like the steps in between. I'm not going to do that. I'm just going to take the derivative all of one step and show you that we can separate them. I guess that separation is for a different video. But so when I take my derivative here, my dy over dx, okay, power rule states that this 5 comes out, and I'll put it out front this time. So 5 times out front multiplication 4x to the power of 5 minus 1. We take whatever that exponent was and we subtract 1 from it. Okay, so we bring it down out front, and then we, for multiplication, then we subtract the exponent by 1. Plus, and we do the same thing actually, or we can do the same thing here with x, right? We imagine there's a 1 out front, if you don't know the derivative of x being just 1, right? But if there's a 1 out front, or the exponent, sorry, and a 1 out front, if we use power rule again, we can also get our answer. So 1 comes down times x to the 1 minus 1 power, okay? So let's simplify this. dy dx, derivative of y with respect to x, is equal to 5 times 4, which is 20, x, and then 5 minus 1 power, right? 5 minus 1 is 4, so we have 20x to the 4th power, plus, well, x to the 1 minus 1, that's 0, right? So we have really 1 times x to the 0 power, okay? Well, anything to the 0 power is just 1, correct? And 1 times 1 is 1. So if I want to rewrite this finally, just to make my final answer, 20x to the 4th plus 1. There we go. Okay? F of x is equal to 4x to the 4th minus 5x minus 3. Okay? Well, if I'm going to derive this, I'm going to be using the power rule a few times, and the constant rule and the sum rule. Okay? So if we're going to find f prime of x here, okay? Power rule states that I bring this 4 down up front, 4 times 4x, and I take the exponent and subtract 1 by it, so we'll do 4 minus 1. Okay? Then I do the same thing here, minus the 5. There's a 1 up front here, right? So power rule says I bring down that 1, so 1 times 5x to the 1 minus 1 power. And then minus just, well, derivative of 3. 3 is a constant. Derivative of a constant is just 0. There. Okay? So now let's go simplify this. So we have f prime of x is equal to 4 times 4, which is 16. X to the 4 minus 1, which is 3. Third power. Minus 1 times 5, which is 5. And then x to the 0 power. And subtracting 0 doesn't do anything. Well, x to the 0 power is just 1, right? And so 5 times 1 is 1. So we have f prime of x is equal to 16 x to the third minus 5. And there we have it. Final answer. Y equals 3x to the 5/4 power. Okay. Well, here this is a classic power rule, but we have a fraction, so let's be careful here. Power rule states when I take my derivative, my dy dx. Power rule states I bring down the power, so 5/4, multiply by what's given, 3x, to the power of 5/4 minus 1. Okay. So now when I simplify this, all right, I have to be good with my fractions. Multiplying fraction times a constant, well, we have dy over dx is equal to, well, 5, the way you multiply that, really that 3 is over the 1, so we have 15x right there over 4, okay? And now it's 5/4 minus 1. Now, sometimes you can't do this in your head. You know, the 5/4 minus 1, little note here, sometimes I'll have to do that. 5/4 minus 1 is the same thing as 5/4 minus 4/4. 5/4 minus 4/4 equals a fraction, is just a 1/4. And so our exponent here is just a 1/4. Okay? Now, you probably could just do that in your head, let's be honest, but if not, make little side notes. I like doing that all the time. For instead of rewriting all the problems for every single step, you make a little asterisk and say, hey, I did this little step here, that's how I'm getting that. It helps you definitely with your notes. But it leaves me with my final answer here of dy dx is equal to 15x to the 1/4 power all over 4. Remember that multiplied by 4, or that 1/4 right there. 4 goes underneath. So the 5/4, 5 times 3 is 15. 4 goes in the denominator, and there we have it. Y equals 5/4 x to the 2/3. Okay? So 5/4 times x to the 2/3. When people see fractions, all of a sudden they start freaking out. Don't worry about it. All we need to do is still follow the power rule here. So dy dx, doing the power rule, taking the derivative, power comes down 2/3 times 5/4 x to the power 2/3 minus 1. Same thing. We take the exponent, we subtract 1, and we bring that exponent, or the first exponent before we subtract it, down in front, multiplication. And I'm writing completely sideways. Let's kind of twist that here at my next step here. So let's simplify this a little bit. Dy dx is equal to 2 times 5, which is 10, over 3 times 4, which is 12. Okay? X to the, now what's 2/3 minus 1? Well, 2/3 minus 1, you need this right here. Well, 2/3 minus 1 is the same thing as 3 over 3. 2/3 minus 3/3 is a negative 1/3. Okay, so to the negative 1/3 power. Okay, now here, this is what becomes tricky. Okay, so what I'm going to do here, I'm going to simplify the 10 over 12 to be 5 over 6. Okay, so we have dy dx equals 5 over 6 here, times, well, x to the negative 1/3 power is the same thing, right? We don't like negative exponents in our final answer. So it's 1 over x to the 1/3 power, okay? And now I can go combine this and be one big fraction. Dy dx is 5, right? Multiply across 5 over 6x to the 1/3 power. And that's how we would write our final answer. Y equals negative 4x to the negative 5th power. Okay? Negative 4x to the negative 5th power. Power rule states, all right, when I derive this, so I'm going to take my derivative, dy dx, then I bring the negative 5 out front, multiplication, so negative 5 times the negative 4x. Now our exponent, we need to subtract the negative 5 minus 1. So whatever exponent was, we need to subtract it right there. Okay? All right. So now let's simplify this out, right? So now we've done our power rule, the negative 5, same thing, just because there's negatives. Power rule still applies. Negative 5 comes out front, and we subtract that exponent by 1, and we keep everything basically the same. So let's simplify this. Dy dx, okay, equals Negative 5 times a negative 4 is a positive 20. And then we have x to the, well, negative 5 minus 1 is a negative 6. Okay? Now, some of you might say this is nice and neat. Kind of is, but we need to write it out. We don't like negative exponents for our final answer. So we know that that negative 6 really can come, that x to the negative 6 power can be in the denominator, making a positive 6. So we have dy dx here is equal to 20 over a positive x to the positive 6 power. And there we have it, our final derivative. Y equals 3 over x to the third power. Okay. Well, there's a few ways you can go about this. I'm going to show you what is one of my techniques I like to do. Before I just hop in and start deriving, what I like to do is to rewrite this function, or where there's no fractions if possible, or just bring all the x's, the variables to the numerator. So to do that, I can write this as 3x to the negative third power. Okay? So 3 over x to the third power is the same thing as 3 times x to the negative third power. But what that allows me to do now is, it's easier for me to see the power rule here. So now when I take my derivative, dy dx, the power comes out front, negative 3 times 3x to the negative 3, and we subtract that exponent by 1, negative 3 minus 1. Okay, so now we can simplify. All right, we can simplify this. So dy dx is equal to negative 3 times 3, which is negative 9. Negative 9, x to the negative 3 minus 1 is negative 4 power. Now, again, I would then rewrite it down, have a positive exponent. So bring the x to the negative 4th, I put that in the denominator, make x to the positive 4th. So our final answer is dy dx is negative 9 over x to the positive 4th power. And there we go. Okay. So long story short, basically, when I'm doing the power rule, I like to have my x's in the numerators, and I don't mind if it's negative exponent, I find it easier. But then at the end, I have to rewrite it to make it where x the exponent's positive, and so it's 1 over, or negative 9 over x to the positive 4th power. Y equals x to the 2/3 power. Okay? Well, power rule states when I derive this, so dy dx. Power rule states I bring that power up front, 2/3, x to the power, now 2/3, we take that exponent and subtract 1. Now, if you're like me, sometimes I like to see this 2/3 minus 1 on the side, but I don't like to write it for all my steps if I have little things like this to do. So 2/3 minus 1 is the same thing as 2/3 minus 3/3. You can't really see this. And 2/3 minus 3/3 is a negative 1/3. Okay, fantastic. So now, when I simplify this, I have dy dx is equal to 2/3 times x to the negative 1/3 power. Okay? Well, if I have now 2/3 times x to the negative 1/3 power, that negative exponent for my final answer, I don't like to write that. So I'm going to bring it downstairs down to the denominator. So we have dy dx, right, equal my fraction 2 over 3, or 2/3, and then we have x to the 1/3 power, positive 1/3. And there we go. We have our final answer. F of x is equal to negative 2 times the 4th root of x. To derive, I really don't like seeing square roots, 4th roots, cube roots, etc. Anything with a radical. Don't like it. I prefer to see them as fractions. So my first step here, I'm going to rewrite this function. I haven't derived yet, or taken the derivative, but I'm going to write this to be negative 2 times, instead of the 4th root of x to the 1/4 power. And we know they mean the same thing. Okay? So now from here, I can apply the power rule. So now I'm taking my derivative, f prime of x, is equal to, well, the 1/4 comes out front, 1/4 times negative 2, multiplication there, x to the 1/4 minus 1. Okay? Well, when if you need a little note here, 1/4 minus 1, you can. 1/4 minus 1 is the same thing as 1/4 minus 4/4, and 1/4 minus 4/4 is negative 3/4. Okay, moving on. So now when I simplify this, f prime of x, 1/4 times a negative 2 is the same thing as a negative 1/2. Okay, I'm kind of simplifying that. Times x to the power here, negative 3/4 power. All right, I don't like having a negative exponent for my final answer. So when I rewrite this, I'm going to write that to be then x to the negative 3/4 power to be 1 over x to the positive 3/4. So we have our final answer, f prime of x is equal to negative 1 over 2 times x to the positive 3/4 power. There, okay? And there we have it. Now, some of my students, some people put a negative out front here or up top. It really doesn't matter. Basically the same thing there. Yeah, don't worry about that. If it's up there with the negative 1, or sometimes you'll see it out front. Just don't do both of those. That's pretty lame. Okay? So we have a final answer of f prime of x is equal to negative 1 all over 2 times x to the positive 3/4 power. Y equals 2/3 x to the 4th plus 5x minus x to the negative 1/3. Okay? So this one, I'm really using the sum rules and the power rules. All right, so power rule. So what we're going to do is use a power rule for basically each section here, each term. So when I take my derivative, dy dx, I'm going to kind of think of the power rule of each part individually. So this first part here, 4 comes out front, 2/3, right, times x to the 4 minus 1 power. Plus, power rule here, there's an exponent that's 1 there, so we have 1 times 5, x to the 1 minus 1 power, minus, power rule here again, negative 3 comes down up front, negative 3, okay, times x to the negative 3 minus 1 power. So now let's simplify all this, right? We're going to simplify each part. So derivative dy dx is equal to, well, 4 times 2 is 8, so we have 8/3 x to the 4 minus 1 power, which is 3, plus, well, 5 times, or x to the 1 minus 1 power is 0, so we have 5 there, so it's 5x to the 0th power, in a sense, and you eventually won't be writing that, okay? Now we have a minus a negative 3, well, minus a negative is plus a positive, so we have plus 3x, negative 3rd power minus 1 is a negative 4th power, okay? So now I have to rewrite this as one final answer. Now, people will debate whether to leave the 8/3 out front or make it a fraction. I'll keep it. I'll make it into like one big fraction, combine it in my last step here, but that's really up to you and what your teacher really wants. I wouldn't care. So dy dx is equal to, simplifying this, well, 8x to the 3rd power over 3 plus x to the 0 power is just 1. 5 times 1 is 5, so 5 plus. Now we have x to the negative 1/4 power. I don't like having negative exponents, so I'm going to bring it down to the denominator. So we have that x to the positive 4th power, but the 3 stays up top, and there we have it. We have our derivative here, which is dy dx is equal to 8x to the 3rd all over 3 plus 5 plus 3 over x to the positive 4th power. Y equals negative 1/2 x to the 4th plus 3x to the 5/3 power plus 2x. Okay? So if I was to simplify this, all right, derive it, take the power rule of each part individually and the sum rule is kind of combining them all. So to do that, I have dy dx. Derivative of this, power rule says 4 comes out front, 4 times a negative 1/2 x to the 4 minus 1 power right there, plus 5/3, next part, same thing, power rule applies, 5/3 comes out front times 3 x to, this is 5/3 minus 1 plus, and then power rule here is really that 1 up there, right? 1 times 2 x to the 1 minus 1 power, okay? And eventually some of these things you won't be writing always, okay? So now let's do some simplification here, okay? So dy dx is equal to 4 times a negative 1/2 is a negative 1/2 x, right? Now we're negative 1/2, right? 4 times negative 1/2 is not negative 1/2, negative 2. Getting ahead of myself here. Ooh, negative 2. I can't believe I did that. And then x to the 4 minus 1, which is 3. Plus, now here, 5/3 times 3, well, 3's cancel, leaving which is a 5x. Now what's 5/3? Let's put it right here. 5/3 minus 1 is the same thing as 5/3 minus 3/3, if you need that fraction, which is now 2/3, right? So we have 5x to the 2/3 power, plus this side here, it's just 2, right? 1 times 2 is 2, x to the 0 power 1 minus 1. So let's do our final little simplification here, and then we're going to be done. We have dy dx is equal to a negative 2x to the positive 3rd power plus 5x x to the 2/3 power plus 2, or x is 0 is 1, so we just have a 2 right there. And there we have our final answer. Y equals negative 3r to the 5th power minus 5r squared. Okay, so my given variable here is r. So when I derive this, my dy over dr with respect to r, right, respect to the r variable, I'm going to be using the power rule. So the power rule still applies just like any other variable. Right, 5 times the negative 3, r to the 5 minus 1 power, minus 2 comes out front, 2 times 5, r to the 2 minus 1 power, right there. Okay, so now we just simplify it. dy over dr. All right, 5 times negative 3 is a negative 15, so negative 15 r to the 5 minus 1 power, which is 4, minus 2 times 5, which is 10, right? R to the 2 minus 1 power, which is just 1, so I'm going to leave it as it is, and there we have it. We have our final answer. dy dr is equal to negative 15 r to the 4th power minus 10 f of s. And I'm going to make my s's like this, because my other s's look like 5's. Negative 3 over s squared minus 4 over s to the 4th. And don't make fun of my s's. Okay? So, if I want to derive this, well, what I like to do, okay, my given variable is s, and what I like to do is rewrite all of my fractions that have a exponent in the denominator with the variable, and I'll bring it to the numerator. So I'm going to rewrite this to be f of s is equal to negative 3 s to the negative 2 power minus 4 s to the negative 4th power. Okay. Now in doing this, I'm going to make sure I keep my negatives in line. I'm going to take the derivative and use the power rule. So we have f prime of s is equal to negative 2 out front, power rule still applied. This means having negative 3 s to the negative 2 minus 1 power minus negative 4 goes out front, negative 4 times 4, right? Power comes out, s to the negative 4 minus 1 power. Okay, so now let's simplify this. F prime of s, negative 2 times negative 3 is a positive 6, so we have positive 6. S here, negative 2 minus 1 is a negative 3. And then now we have subtraction here. Negative 4 times positive 4 is a negative 16, and plus and minus a negative, same thing as plus a positive. And then we have s to the negative 4 minus 1, which is negative 5. Okay? So now that I've made everything to a negative exponent, I'm going to make them all to be positive exponents by putting them in the denominator. So simplified, my final answer, f prime of s, is just 6 over s to the positive 3rd power, right, plus 16 over s to the positive 5 power. And there we have it. Final answer. F of x is equal to 2/3, that's a 3, 2/3 x to the 3/2 power minus 3/4 x to the 3/5 power. Okay? Well, what I'm going to do here is I'm going to do the power rule to each part there. Okay? So when I take f prime of x, okay, I'm going to bring that exponent down 3/2 times what was given, 2/3 x. And then I'm going to take my exponent and subtract 1 from it. So 3/2 minus 1. Okay? Then we have the minus here, minus sign, that one right there going down. Then this exponent we bring down 3/5. And then we're going to have times that 3/4 x to the 3/5 power. Okay. That 3/5 power, though, we had to also subtract, almost forgot there, a 1 from it. We decrease the exponent by 1 as well. So if you need little notes on the side, let's do the, well, let's make a little note here. What is 3/2 minus 1? Well, 3/2 minus 1 is 3/2 minus 2 over 2, which is 1/2, right? And so when I simplify this, I have f prime of x here. I multiply 3/2 by 2/3. Well, really, look, the 3's cancel, and the 2's cancel, so we're left with just 1. So we're just left with the x there, and the exponent 3/2 minus 1 is just a 1/2 power. Now we have minus here. So now when we multiply these two numbers, 3 over 5th, 5 times 3 over 4, we multiply across, so 3 times 3 is that 9, and 5 times 4 is that 20. So we have minus h of s, and yes, these are my s's, is equal to the square root of 2 times the third root of s plus the square root of 2 times the fifth root of s. Okay. One thing to note that these two square roots of 2 up front are still constants. There's still these numbers there, right? It's a number in front of what's going on there, right? The cube root of s, the fifth root of s. So be careful with that. A lot of students try to derive those, and you can't. They're still constants. They still have all the rules of constants there. Well, what I'm going to do before I derive anything, I'm going to rewrite these instead of the cube root of s to be s to the 1/3 power, and the fifth root of s to be the s to the 1/5 power. And I like seeing fractions when I apply the power rule. So square root of 2, this is s to the 1/3 power plus square root of 2 times s to the 1/5 power. Okay. Well, now I can apply the power rule. So apply the power rule, you bring the fraction of the exponent down, and subtract the exponent by 1. So we have h prime of s is equal to 1/3 times the square root of 2, s to the 1/3 power minus 1, plus here, 1/5 comes down, 1/5 times square root of 2, and then it's s to the 1/5 power minus 1. Okay? Well, hopefully we're getting better at 1/3 minus 1, but if you need the note here, if I want to show the 1/3 third minus 1 is the same thing as 1/3 minus 3 over 3, which makes it easy to see negative 2/3 right there. The same thing here, that little note here, 1/5 minus 1 can be 1/5 minus 5/5, which is the same thing as negative 4/5. Okay? So let me simplify this up here. And in doing so, what I'm going to do is kind of combine everything. So we're not going to, but I'm sorry. Getting ahead of myself there. So 1/3 times square root of 2, and this is now s to the 1/3 minus 1, which is negative 2/3. They're 2/3 power, plus 1/5 times the square root of 2. That's s to the negative 4/5 power, which we found on the side. So now I don't like to have my exponents to be a negative number, so I make a positive and put them in the denominator, common technique. So we have h prime of s here is, and now I'm going to do this and combine them all together to, here's the combination part, to one big part. So we have the square root of 2 in the numerator over the 3, right, that 1/3. But the s now goes down to the denominator, and it's, instead of a negative 2/3 power, it's a positive 2/3 power. Okay? Then we have plus here, square root of 2 over the 5. And instead of, again, the s being the negative 4/5 power, it's the denominator, and it's going to be a positive 4/5 power. And there we have it. Our final answer here, which I forgot to put a little parenthesis around the s there, where h prime of s is equal to square root of 2 over 3 times s to the 2/3 power, plus the square root of 2 over 5 times s to the 4/5 power. This function, y equals 5c. Okay, that's 5 times c, which is fine, 5 times c. And I wanted to derive that. Well, the key thing here is to tell us that c is a constant. What constant is it? I don't know, but it has the properties of a constant, some number. What that allows me to know is that, well, 5 times c, 5 times some number, is just some other number. Okay, it's still going to be a constant. And when that is the case, dy dx here, when I take the derivative of any constant is just 0. And there we have our answer. Y equals 4ax to the 3a power minus bx to the 3c power. Okay. Well, so again, let's remember our constants are a, b, and c. Okay, so the only variable here is actually the x and then the y. So what I'm going to do here is I'm going to apply, when I derive this, the power rule. Okay, so let's keep everything noted here. We take the power rule, so we're taking derivative dy dx. Okay, power rule still states the power comes down, so 3 times a times what's left, 4a, whatever those numbers are. These are some constant, 4 times a, right? X to the 3a, where the power is, we subtract 1 from it. Then we subtract here, the other side, well, the power comes down, right? whatever 3c is, I don't know what that constant is, but it's 3 times c, times b, x to the 3c, the exponent, but we still have to subtract 1 from that exponent, okay? So now I want to simplify this, okay? Well, to simplify it, well, I know I can multiply my numbers out here across, right? So I know I can do my 3, so my dy dx here. 3 times 4 is my 12, okay? And a times a is, I don't know what a is, but I know it's a squared, right? A times a is a squared. So we don't know what a is, but we know a times it's a, whatever that constant is the same thing as a squared. We have our x here. Now 3a minus 1, we don't really know what a is. We don't know, what that number is going to come out to be. So we leave the exponent to just be 3a minus 1. Then the right side here, okay? Well, 3 times c times b, let's go alphabetical order. It's called 3bc, right? 3bc, x to our exponent now of 3c minus 1. Again, we can't subtract 1 from 3c because we don't know what c is, that constant, to adapt it or change it in any way. And that's it. We actually have our final answer here. It kind of looks pretty complicated, but it's dy dx is equal to 12a squared times x to the 3a minus 1 power minus 3bc x to the 3c minus 1 power.
Minute Math. When you need help, you use Minute Math. Minute Math. When you need help, you use Minute Math. MinuteMathTutor.com.